Welcome back to We Dared Chemistry. In this lecture, we will spend our brain about the dual behavior of matter, so join us whether you are a student or a curious mind. In 1924, French physicist de Broglie proposed that matter, like radiation, should also exhibit dual behavior, i.e., both particle and wave-like properties. This means that just as the photon has momentum as well as wavelength, electrons should also have momentum as well as wavelength. Solution. Relation. De Broglie, from this analogy, gave the following relation between wavelength, lambda, and momentum, p, of a material particle. Lambda equals h divided by mass into velocity equals h divided by momentum. Finding. Where m is the mass of the particle, v its velocity, and p its momentum. De Broglie's prediction was confirmed experimentally when it was found that an electron beam undergoes diffraction, a phenomenon characteristic of waves. This fact has been put to use in making an electron microscope, which is based on the wave-like behavior of electrons just as an ordinary microscope utilizes the wave nature of light. An electron microscope is a powerful tool in modern scientific research because it achieves a magnification of about 15 million times. This was the relation of de Broglie. Thank you for your attention. Keep studying with We Dared Chemistry.